Welcome everybody. Thank you for coming. And if you look at the program, it says I'm going to tell you, I think, 10 interesting things about Dotty, which I will do, but that will only be the first 15 minutes or so, and then I will show you something that is, I think, quite cool. But we'll see. I'm going to jump straight in and go through this quite fast. These are just like a few of the things that are going to be in Scala 3 that I'm a little bit excited about. And hopefully I can sort of inspire you with some of that same excitement for what's coming in probably little more than a year from now. Enumerations. So you're very familiar probably with this sort of code in Scala 2, where we define a sealed trait with some number of case objects or sometimes case classes which are subtypes of that sealed trait. It's 4 lines of code to represent what is effectively an enumeration. Dotty, or Scala 3, as I should really call it, reduces that to a single line. It gets... You'd love your applauses, don't you? Are we going to cheer every single feature of Dotty? We can also do more advanced examples. So this is some sort of representation of a list. It's very similar to the one that you will see in the collections library. I've called cons with an alphanumeric name rather than the colon version, but essentially that's the code you have to write to define the ADT that represents a list. Again, we have a sealed trait. We've got two possibilities. One is the empty list, nil, and one is cons, which joins ahead to another list. In Dotty, that can be expressed as simply as this. I think that's more impressive than the enumeration, the color example. You see, we've got the type parameter defined just once. We have nil and cons defined here, 1 line each. We don't even need the type parameter t to be specified on cons. We can refer to it here and here. And it's basically not a lot more information, or not a lot more boilerplate, than you would expect if you were explaining it to someone. There's not more information there than you need. Possibly the only criticism you could ever have is that case is written twice, but I don't see that as a huge problem. We can even add a method on there. So that method size can be defined for both nil and cons. Because we're not defining on the subtypes themselves, like nil and cons, we define it in terms of pattern matching. That's a requirement, but essentially we have one definition which works for both. It'll, of course, do the checking that would be done by, in the case where it's a sealed trait, it checks that you handle all the cases, so it's a total function. So we get a lot more, I think, expressivity in terms of things that should be simple are actually simple. Speaking of simplicity, type lambdas. How many people here are familiar with this sort of syntax? So probably about half of you. That's good. In a way, that's good to see. In other ways, it's maybe less so. This syntax was not designed. It was more discovered by combining some combination of features. We've got a projection type. We've got a type constructor definition. There's a type alias there. We've got an anonymous type refinement. And by combining these features, which are sort of independent and orthogonal to each other, someone, I don't know who it was, Jason Zaug, discovered that it was possible to get what is effectively a type lambda, which is a way of, in this example, changing the kind of a type. Now, if that means nothing to you, don't worry. If you don't know about it, you probably don't need to. And I don't have time to explain. But you would use it, for example, as a parameter to a functor. But it really looks horrible. We've got 3 layers of nested brackets there, different kinds. Every layer is necessary. And it just looks difficult to understand, and in many ways is. Whereas in Scala 3, we can write something like this. What that's saying is, if you give me a type, t, I will give you a type back. And the type I give you back will be either with the t substituted into the position that it's specified in. That looks very similar to a lambda at the value level. And it is... The only real difference is that we have square brackets around here, and it will only ever appear in type position. But that is, again, as simple as I think I would like it to be. It's very similar to what we've had with kind projector for several years now, but now it's going to be a part of the language. And that's what it would look like in an actual usage if we were creating a functor. You may also see code like this in Scala. Now, people write this because they want to unify a type, or a value, sorry, a type inferred from a value that is passed as a parameter to this rather useless getHead method. And what the compiler can do is, if you pass it, say, a list of int, it can work out that the t is an int and the collection is a list. That's something the compiler does all the time, type unification. And it puts this constraint on to check that the list is a subtype of a sequence. This is what you should write if you want to do that. What people frequently do is they write this. Does anyone know what the return type of this would be? Any. The return type is any, because although we confirm that the collection that gets inferred under unification is a subtype of sequence, we do nothing to bind the type parameter of sequence to the type parameter of collection. Consequently, we know nothing about what the head type will be, so it just assumes any. This is not what you wanted. In Dotty, we've just got a simpler way of writing that avoids the confusion completely. We can say that the inferred collection type is a subtype of sequence, but we don't need to specify the type parameters here. We don't need to say they're linked. It's inferred that they are. And in fact, the kind of the col, the abstract col type, is also inferred from the fact it is subtyping sequence. So this, I think, is nicer. It avoids a possible trap that people may fall into. Dotty has implicit function types, and Martin has spoken about these at the last couple of Scala days, if I remember correctly. One thing I don't like about his examples are that they require constructing some structure of objects involving side effects, and I have an example that is somewhat more complicated. If anyone came to the talk I ever gave about impromptu, then excuse me. Talks I gave about impromptu a year or so ago, I would have shown you this code and explained it. I'm not going to do that today, but I will show you some code that uses impromptu. Impromptu allows you to combine a few type-level features to construct a graph of asynchronous computations. And it puts the necessary constraints on such that you can't access a value that hasn't been computed yet. It's encoding in the type system the constraint that you can't accidentally reference a value which is not complete. And the syntax you get at the call site in Scala 2 with impromptu is this. We define some nodes in our computation graph. They're not doing anything particularly interesting, they're just calculating numbers. And we add the constraint that the work that's done in here must be done after alpha and beta are done. And I use this implicit parameter here to add the constraint that we can only access the value inside, which is done with the application there, if this implicit evidence provides the proof that they are completed. So there's a few constraints going on here, but we get type-level constraints on guaranteeing that we don't accidentally have we don't accidentally try and use the value of a future that isn't complete. But what annoys me about this is that every single node here has to define this implicit environment. It's boilerplate. What we can do with Dotty is we can write it like this. We don't need that. We can refer directly in here to the values alpha and beta. We can apply them. These will take implicit parameters which will find an implicit in scope that we don't need to write because it's provided through an implicit function type. So that is the syntax I always wanted. I had to use this before. Now we get this. And the cost of that is at the definition site now, and it just means the addition of this implicit keyword here. So, complicated example, but the benefit that you should take away from that is that the syntax at the use site, so it gives us an example of a case where the syntax at the use site is somewhat simpler. We also have named type parameters. We can define a type class, for example, converter, which is a very general type class that converts from one type to another. And let's define a couple of examples from converting strings to integers and strings to doubles, using what I think is the obvious, ignoring exceptions, but doing the obvious thing. I'm pleased that people are laughing about my lack of handling of exceptions here. But for the simplicity of the example, we're just going to provide these two possibilities. And we can define a method, convert, that we can call anywhere, which is going to take a value of the type from, and it's going to use that to find a converter, which we can then use to convert the value that we provided. And the return type we get will be the to type. Now, if we try to just call that convert method with a string, we get ambiguous implicits. Remember, we provided a converter from string to int and string to double. It has no idea which one to choose. Or we could specify that we want the int one. We also have to write string there because, I mean, we could work it out that it's a string, but Scala-2 requires that we specify either all of the type parameters or none of them. There's no default or named type parameters. Dotty will allow us to write this. We can do one other thing in Dotty, which is to put the we can write the implicit as a context bound using a type lambda. That is valid syntax in Dotty. But more or less the definition is the same as before. And we can specify just the type parameter we care about. The other one will be inferred from the argument here. So again, we're not providing more information than we need. Now this is more of a problem when you have many type parameters, and usually they're all inferred, and then there's one annoying one which doesn't get inferred, and you need to specify it. But Scala-2, you specify all of them. This doesn't work, though, in Dotty. I would be interested to see if this could be made to work, where we want to have an either value where we can infer some part of it from, we can infer some part of it in here, that the right type will be an int, but we need to specify that the left side would be a string. This isn't valid Scala 3. I will maybe propose it as a possible enhancement. Dotty has erased terms. Does anyone ever write code like this, where they have a subtyping constraint? The reason we write this as an implicit, which is confirming that the type T is a subtype of the type S, is that if we put the constraint on the parameters there, then that would actually influence the inference. And maybe we don't want that. Maybe we want the inference to be inferred only from the two parameters we provide. And then after they've inferred types for T and S, we want to check that there is this constraint valid. That's the reason why we write it like this. Now we get that evidence, and that is proof that that is the case, that T is a subtype of S. But we don't ever use that. But nevertheless, that will be compiled to Java looking something like this. It'll be a 3-parameter method, and this evidence value will be passed to it, even though, like I said, we don't use it. In Dotty, we can use this erase keyword, prefixing the evidence. And what that will mean is that will be compiled down to this instead. There won't be that 3rd parameter for the evidence we're not going to use. And that adds the constraint that we can't actually refer to that evidence parameter in value position unless we're passing it to another method that erases it. So this is an example, a very trivial example, of where we have that evidence. We are allowed to use it in value position here, but only because the method we're calling, perform, takes it as a parameter which is itself erased. There's no requirement that erased parameters are implicit, so this is an example where it's an explicit erased parameter. And you can also have erased values. You could say, believe me, T is a subtype of S, because maybe you know more than the compiler. And that will compile to nothing at all, but it will add the constraint, or it will satisfy a constraint if one is demanded, proving that T is a subtype of S. So that's going to be a performance enhancement for certain kinds of code in Scala 3. We have dependent function types. If we had a type class representing default values for a particular type, so int would give you a 0, string would give you the empty string, we could define the type of the get method of that, something like this in Scala-2. So given an instance of a default type class, we will get back an instance of the type. And the key thing is that that t there is the same as that t there, which is why we make this existential bound on them that confirms it's the same t. Now this is, in some sense, correct. It's what I wanted to express, but the compiler is very bad at doing inference around existentials, and I'm not actually sure you can usefully use this constraint in many different scenarios. In Dotty, we get the ability to write that same, or we can express that same thing in a much neater way. We can associate a value with a type, and we can have the return type dependent on that value that is passed into the to the function. This is the functional representation of a dependent method type, where the return type of the method is dependent on the parameters. So this is, again, nicer, simpler, I think easier to understand than that existential. Maybe some of you haven't seen this syntax before and it looks very confusing. You're right to be confused. This, I hope, is more meaningful. I'm going to rush through the last few. Safer equality. This will not be allowed in Scala 3. You can't check whether something which is an integer is a string. And there's also multiversal equality, which I won't talk about, but essentially this is a compile error, not even a warning. It just won't compile now. And the best feature of all, if, then, and else, we can use the then keyword instead of writing code like this. We don't need those parentheses anymore. We can just write that as if a equals 0, then nil, else list of 1, 2, 3. Isn't that great? That needs a round of applause. Maybe not the most dramatic enhancement to the language. And just to wrap up, there is a huge topic around principled metaprogramming. Different approaches to doing metaprogramming in Scala. It's interesting that by calling it principled metaprogramming, it sort of implies that the previous methods of doing metaprogramming, i.e. macros, were very much unprincipled. It's also interesting that Eugene Bamarco is working on the reasonable Scala compiler these days. So we have a few different features: type rewriting, quotes and splices, possibly not inline transparent methods, but some sort of inlining happening automatically. Miles is maybe the person to ask in a couple of months. Yeah, we'll see. But I don't have time to talk about all of those today. So with all of these new features, I'm quite excited about what's coming. I'm excited about other details like the provable soundness of the type system and the confidence that should give us. But we have tens of thousands of people using Scala 2 still. They're all using the Scala C compiler. And somehow, over the next probably few years, we're going to have to migrate. I hope we will migrate. I hope we don't end up in a continuum like Python 2 and 3 where they existed, or Python 2 continues to exist despite Python 3. I think that won't happen because we have static checking of our code. Python didn't have that. I think the argument that that we will stick with both is unlikely to be true for a number of reasons, but primarily that we do actually run our code through a compiler and it can check everything for us, which is a luxury that Python doesn't have. But we can expect, in any case, Scala 2 and Scala 3 to exist for some period of time together and to have projects that use both. We would probably like that to be shorter rather than longer. Any transition period is going to be more challenging than not having a transition. So I think there will be a number of projects, many of them open source, which will be in not just an ephemeral state of transition, but a long-term state of transition where they are being migrated slowly. Maybe Dotty is adapting as the projects are adapting, with some features being re-implemented completely, others being tweaked, and others just working out the box. But we're going to have more builds which involve Scala 2 code and Scala 3 code together. And I think that our approach to building Scala that we've been following for several years now really needs to be more flexible. I think that the idea of having to publish binaries to a central repository only when all of the dependencies of that project are published means that we end up with a system, an ecosystem, that is sclerotic. It is very slow for changes to be dispersed throughout the entire system. If I want to publish my library and I have dependencies on 5 other libraries, I have to wait for those other 5 libraries to publish their binaries first. I have to wait for the authors of the 5 authors of those libraries to publish, and they have to wait for the authors of their dependencies to publish. This is why it takes some projects a matter of months between the source being ready to the binary being published. And this is very problematic. It means that the projects at the top of the tree, such as Scala.js, that puts a burden on Sebastian Duren, who publishes and maintains Scala.js, to publish as soon as possible, because he is holding up the entire ecosystem if he doesn't. And he does not take vacation when a Scala release is coming, because he knows that he needs to be around to make that, to publish the binaries. Bill Venners actually pays someone. He's an open source author. He pays somebody else to publish for him, so he doesn't have to. That seems wrong to me. And I think people elsewhere in the tree have different experiences of sort of waiting and then pinging other authors to try to publish their versions. And I'm not very good at publishing my libraries to new versions of Scala when they come out. Everything is too slow. I think it should be minutes rather than months that we're waiting. So I want to have a fresh new approach to defining and using builds, but one that can coexist with established solutions such as SBT. And I added this point when I saw a talk that Runar gave in Gdańsk last week. And he basically said everything needs to compose. And I think the builds need to compose as well. So that seems like a good thing. I'm going to give you a demo. But before I do, I'm going to invite you to a conference next year. I am, against the best advice, I am running Scala World next year, and it'll be in the Lake District. And it's going to be more, I'm going to do my preparation earlier this time. And tickets are actually going on sale in about a week from now. Now, the website is live at scala.world. The tickets, I announced the prices, will be, for the first 50 only, €320. We don't use pounds anymore. Euros. And then they get progressively more expensive as they sell out. So if you're quick, if you're early, you can get a very, very good value ticket. It will be 2 days of hiking and outdoor activities, 2 days of conference, and then an optional day of workshops. It's great fun. People tell me that anyway. I truly believe it is, and you're all very welcome to come. So please feel invited. Meanwhile, I'm going to show you. A demo. There we are. I'm going to demo my contribution, I think, to helping to improve the build situation for Scala over this difficult period of transition as we migrate to Scala 3. What I'm going to do, rather than explain all of the details and the models behind Fury, is I'm just going to use it, and I'm going to show you what typical usage of Fury would be for someone using it on an everyday basis. And I've got a little script here, and what I'm going to do is create a new project and build it. So let's just create a new directory called, I've already got scala-italy, let's call it scala-italy 2. And to begin with, I'm just going to initialize that as a workspace. And I do that with Fury init. And in the background, it's asking for my password, which I will just type in. And ignore this. By the way, if anyone knows why this is happening, please tell me. So we now have an initialized repository. You can see there's a little asterisk there, which indicates that we have something going on in this directory, and we have a file. This is now a workspace that we can use for Fury. What I'm going to do is add a project. That seems a reasonable thing to do. So I will note how I get tab completion. And I'm going to call this, what should we call a project? Let's call it website. So our current project is now website. And we can see this by listing the projects. There's just one project there, and it's website. It doesn't have a license. Let's set the license to Apache 2. Okay, so we've now got a website with a license. I can't be bothered to add a description, but there is the facility to do that. Can everyone see the font? Okay. Is it big enough? If it's not, I can't make it any bigger. And inside our project, we want to have potentially several modules which will compile one by one. So let's add a module, and let's call that core. Seems a reasonable name for a module. It's like a submodule in SVT. It's basically equivalent. It's going to correspond to one run of the compiler. So we've got our module. Let's just show that. There is the module. Not much information, no dependencies, no source, no binaries, not even a compiler. So we're writing this project. Let's start by adding some code. And I'm going to put that into, I'm going to create, let's call it core. Actually, I've deviated from my script, which is always a disaster if you're doing live coding. And let's have a backend as well. These are going to correspond to two modules. And let's have a look at, let's add some code to the backend. And package backend, that's fine. Let's just add the minimal amount of code that will actually do some compilation. And let's have a look at the front end as well. What should we put in there? Let's have a sealed trait called, I don't know, door. And case object open extends door. Three states for our door. Okay. I hope that's valid. We'll find out if it's not. Now, what I want to do is associate that source I've just created with one of the modules. So let's add the source. That needs to be a capital S. And I got tab completion there. And tab completion offers me two possibilities because it's found in my working directory there are two folders which contain any Scala sources. So we're going to add to the core module the core source. There it is. It's now listed there. And I'm going to add another module, which will be, let's call it backend. That, I think, is all I need. And we'll add the sources to that as well. So when I add the module, it changes that to the current focus. So it's very easy to just add something and then modify it a little bit, then add something else and add something to that. You can always switch back to it, or you can specify in each command which one you want to modify. So I'm going to add the source backend to that module there. And what I probably want to do as well is add a dependency between them. I want the backend to compile before the core. So, or maybe I want the core before the back end. Let's do it that way around. So let's add a dependency. And I'm going to add a dependency on, so I'm going to depend on core, and I'm going to be modifying backend like that. And there we can see we've got this table which is showing us, I mean, it's a little bit too wide for the terminal, but it's showing us that we've now got a dependency on core from backend. We've got the sources specified. Can anyone see any problems with this yet? No compiler. That's going to be a huge problem. Okay. So let's add a compiler. Now, maybe there's a compiler on my hard disk, but what I want to do is depend on another build that provides me with a compiler. So first of all, I have to find somewhere that, or I have to define somewhere that has a definition of compilers. And there is a published Fury build that defines compilers. So I'm going to just add that build, or I'm going to import that, so I can then use those compilers that are defined inside. What I'm effectively doing is importing an entire workspace into my own. So I define a workspace, I publish it, that's got the compilers. I then have a different workspace which depends on that one I've just published, and I get access to all of the projects that are in there. First step is to add a repository, or link to the repository which contains those definitions. And I'm going to add that repository, and I can use shorthand here. This is GitHub, and I don't need to do git at github.com, and so on. It's GH. You can use BB for Bitbucket, or GL for GitLab. And that is called base. And that's already cloned, in fact, because I can see in the list of repositories that are currently associated with the workspace, it's added the base there. That is where the remote is. It's tracking master, and that is the commit, which it only knows by virtue of having cloned it silently in the background. So now, hopefully, we have a compiler. Let's have a look. I can list the, oh, we don't, because I've forgotten one thing. I've associated myself with the repository, but I haven't actually imported the project into my current workspace. Let's do that. Import, we're going to add an import, and if I press tab, from the base repository, I have an option of 3 different, what I'm going to call schemas. Let's use Scala-212. So I've imported that. Let's check what projects are now available in my workspace. We've got Dotty and we've got Scala. Okay? And what I want to do is update those modules to set the compiler. Well, let's specify for backend first. The compiler is going to be Scala. And we're going to do the same for the core module. I'm so far deviated from my my script. I'm getting scared now. When you've written some software which is changing every day, and you've got a script which you knew worked in the morning first thing, you're reasonably comfortable that everything's going to work when you demonstrate it. But then when you deviate from the script, anything could happen. Let's list the modules. Okay, we've now got compilers, we've now got sources, we've now got dependencies between them. Does anything remain? Well, maybe we would like to add some dependencies on some more interesting projects. And what I can do is I can actually depend on, I can, like I did with the base repository, I really have deviated from my script. Let's just run the build. What this is doing is it's starting Bloop, and it's compiling the 2 modules step by step and reporting what happened. Now, the links between them are very simple. We only have 2, and we get a very, very simple compilation graph there. That was kind of easy. And what I would maybe like to do, having compiled this code and got it working, is perhaps I would like to publish it to make that work available to somebody else. Seems reasonable. Now, how many people here have published a Sonatype successfully? more than I would ever dream of. Okay, it is possible, but it's difficult. With Fury, what we can do is we can just say, first of all, I want to specify a remote place to publish this to. I'm going to publish it to GitHub, and I'm just going to use the hub command, which is nothing to do with Fury, but I can create a new scala-italy repository on GitHub. And what I can do is say Fury workspace publish. Now, I want to sign what I'm publishing. I want people to know that I have verified it myself and that you should trust it. At least you should trust it as much as you trust me, however much that may be. So I'm going to specify a key. Now, it connects to GPG, and it's got several keys of mine available there. And I'm going to tag it as version 1. If I hit enter, it commits the tag. It connects to GitHub, and that is now published. And it's available on my repository for any of the 0 users of Fury out there to depend upon. Maybe in the future there will be more users of Fury, and they will be able to take advantage of that project which I've just published within seconds of me hitting the publish command. So that, I think, was significantly easier. I mean, I didn't cover creating my GPG key. That's something maybe you've already done, maybe you need to do. But that, I think, was pretty easy. Well, I'm not publishing a binary to GitHub. I'm publishing the build that refers to the, it's a good question. I mean, it publishes just the build, which is that file there, along with the signature. Yeah, sorry. I mean, I probably wasn't clear. So that gives someone the ability to clone that, clone that build with Fury, and Fury will then go and fetch the necessary repositories, which it depends upon. What I want to show you, maybe you've seen the tweet I made a couple of weeks ago. Bigger projects are more interesting. If I try and build Fury itself, now if I first of all clean this project and then build it, this is what it looks like to have Fury building Fury. These are some number of projects which I have defined in my more comprehensive build, and it's doing several in parallel at the same time. And it's going through them step by step. This work is being dispatched to Bloop, and you can hear my laptop getting warmer. See, I'm not faking this. And eventually it will compile all of the modules, and we will end up with the class files for Fury. This step is a little bit slow. Sure, it was faster before. Okay, so 57 seconds. Sometimes it's about 20 seconds. So that could be your experience when developing with Fury in a more complicated project, and you get an instantaneous graph of all of the dependencies between your different modules. So it should hopefully be very clear to you, more or less instantaneously, what the build is doing. I want to talk about one more thing, which I think is going to be increasingly important when we have Dotty, which is support for cross-building. Now, SPT has support for cross-building, and it's a little bit ad hoc. It takes a bit of work to convert from building just Scala for the JVM to a combination of Scala.js, Scala native for Scala 2.11, 2.12, and 2.13. What Fury does is it takes the entire workspace and gives you the ability to make a variation on it. I call those variations schemas. You can create as many of these as you like, and they can vary in any way you like, and you can give them a name. So one variant of my Scala 2.12 schema may be a Scala 2.11 version, or, in fact, a Dotty schema. So let's try and add a new schema, and maybe I can actually go back to my script. So at the moment, we only have the default schema. I'm going to add a new schema called Dotty, like so. And I got the parameter name wrong. It should be name. And it's actually called Dottery. Actually, I don't want it to be called Dottery. That's going to be annoying. Let's undo that and call it Dotty. Undo was the new feature I added this morning. And it has proved to be useful. And we now have the Dotty schema. But at the moment, that's identical to the default schema. So what I would like to do is start to vary it. So let's add some different sources. So let's add some Dotty sources, and let's call it some code, and that's going to be, let's use some fancy new syntax. So we're going to create a door. We don't even have syntax highlighting in Vim yet. Case open, closed, ajar. So we've got a one-liner where we previously had 4 lines for that same code. Here's my list of modules. We're currently focused on the back end. Now, I can't remember whether the back end code was boring, wasn't it? It's the core we're interested in replacing. So in my Dotty schema, I don't want to depend on those Scala-2 sources. I want to depend on the new Dotty sources I've just added. So I'm going to add the source for just the Dotty. Oh dear, I've got a bug there. It's only a tab completion bug, don't panic. And I'm going to add the source on Dotty to the module core. I didn't get tab completion there, maybe that was just another bug. But now we have 2 sources there. We want to get rid of this one. So I'm going to say source delete for the schema. That's not schema. For the schema, still don't have tab completion. We're going to delete the source. Oh, we need to specify the module first, which is going to be core. And the one we want to delete is the original core. So this is looking more Dotty-like. I need to change the compiler. So well, let's just choose the right module. So we're going to select the module core. I'm going to update it to set the compiler to Dotty. There, not that. List, and that looks okay now, I think. We've got a Dotty compiler, we've got Dotty sources, and I'm going to select the module backend and try building. And what this is doing is it's compiling core with, oh, did I get them the wrong way around? Doesn't matter. It's compiling core with Dotty, and then it's compiling backend with Scala. That was invoking Dotty. We just got Fury to build a project with Dotty and Scala, and there's very little evidence that it actually did that. But say you came across, I've got what, 2 minutes left. Say you came across a build, you didn't know enough about it, you wanted to just find out more information. You found out in the previous talk that data is king, and by virtue of using a data format for, I mean, this isn't big data, this is tiny data, but by using a data format for my builds, I can very quickly reason about them, and I can reason about things like the differences between them. So, for example, I can compare my current schema, I can do a diff between that and the default one, and that will give me a list of all of the differences. So if I'm maintaining some number of different schemas for different cross builds, for Scala.js, and these can vary in any way. They could have modules or not have modules or even have whole projects. They could have different compilers. They could track different repositories with different commit hashes. They can differ in any way that an entire workspace can differ. But it's very important that you, as the user of the build, get a clear overview of what those differences are. Otherwise, it's challenging to make sense of it. Here, we only have 2 differences because I made a mistake earlier where I actually changed the compiler to Dotty for all schemas. If I change the schema to... we should have an additional entry there saying that it's using the Dotty compiler rather than the Scala compiler. Let me fix that, and then I will finish up the demo. So let's select the schema default because I want to change the compiler not to Dotty. So I want to Fury module update, and the module is going to be core. The schema is going to be default. There's my bug again. I really need to fix that. And the compiler is going to be Scala again. And if I do the diff, I'm diffing it with itself. If I diff it with Dotty, we now have listed that there is this difference in compiler between the default and the Dotty variant. And you could have any number of schemas. You could be you could compile for different target backends, so JVM, LLVM, and JS. Different versions of Scala, 2.11, 2.12, 2.13, and Dotty. You could even have a variant that doesn't depend on sources, but depends on binaries that you fetch from Maven. That is also a possibility, this ability to add binaries. If you had a schema that depended only on binaries, maybe you could even publish that to Maven Central. So if you can develop fast using source dependencies, you don't have to wait for anybody else to publish. If an author doesn't publish their library for Fury, then just do it yourself. The build is defined externally from the project. So you've got the ability to do that. The whole ecosystem can progress. It can make progress towards fast releases. And hopefully we'll no longer be waiting upon many other authors of libraries to publish, burdening them as open source developers with one of the least pleasant aspects of being a developer, publishing. So I hope that is exciting. It's a little way away from a full public release, but I want to have a private beta in a few days. I'm close enough now. I think what you've seen there's a couple of issues, but nothing particularly major, and it's working. So I will share this with a few people. I don't want to do a fast rollout, because if I make a mistake, I can be creating lots of legacy builds that I will have to maintain in some way for potentially a long time. So I'm going to be careful about how I do it. So apologies that you don't get this straight away, but within a week, I hope, private release. Within a month, more users, maybe 30 people, and then by the end of the year, I hope it's available to everybody to use and to experiment with. So that's it. Thank you for listening.
Thank you so much, John. I don't think we'll have time for questions, so you may try to get in touch with him outside.
I'll be around for the next couple of hours. I'm leaving early, so please find me outside after Miles's talk, and I'll be happy to talk about Fury, or anything, in fact.
Thank you so much.
Thank you.